So as the lecturer suggests, he actually go through a few stuff of applications of the composites. Alright, and this also introduce us with a new somewhat a chapter, right, into fiber reinforcement plastics, or FRP, in other words composite. Alright, so we are now talking about composite materials and its processing. Alright, it's still talking about particle reinforced, fiber reinforced and structural, but in terms of its application and then advantage and disadvantage and different reinforcing agents and summary of their density and strength. So this is when I would highly believe that the rest of this chapter will talk about all this, or maybe most of the stuff. But anyway, so let's talk about the applications in this case. Alright, in this last part of this lesson. So I'll not go through all. I'll only go through the important points. So at least when you write the theory part, at least it's easier to write. So what do I mean? Over here, you just need to focus is that for aircraft, alright, lightweight is the most important criteria. Why lightweight? Lightweight itself can help you to reduce the amount of fuel consumption. This means cost. Alright. You can say that the recent trend is that the composite itself is coming up to be a very big portion of designing the aircraft. Alright, the aircraft body itself, as you can see, the color is the same. Alright, so the color represents the amount of composite used for the aircraft. As you can see, the wing, the aircraft bodies and things like that are all in terms of composites, or the rest are all other stuff. Okay, same as the fighter plane. Then composite in healthcare, you can talk about is talking about the cosmetic issue where you have a composite color, white color, for your decay tooth. So with this in case, alright, such that it is pretty useful for your tooth. So is the color itself can be at least people, if you got everything black then people see like, your teeth sucks. But if you have everything nice, then your teeth not bad, sexy. So the proper name is composite filling with tooth color plastic and glass mixture. Alright, so you're gonna memorize this type of stuff, right, to restore decayed teeth. So yeah, these are all applications. And this thing also focus on lightweight for the bicycle and for the Kevlar. Alright, the Kevlar is hard, or is hard and it's strong in terms of, I think it's most probably hard lah. So it is good for resistance against penetration and things like that. So you can utilize all the hardness and everything about the composite, and because metal itself is hard, but however it is also heavy. But for composite it's hard, or you're taking only selective properties. So you select hardness, or for the composite, and while having hardness you also have it to be lightweight, things like that. Alright, so at least it's pretty much good. Over here at this last page, alright, is that the key things for all the composites application is that it has a high specific strength. Definition is also known as the strength to weight ratio of your material. Alright, so with high strength, low weight, then is a high strength to weight ratio, things like that. Okay, so therefore this is talking about that. Alright, so you have a high strength to weight ratio, this means that you are lightweight, okay, compared to other fibers. Alright, so I think the Kevlar fiber epoxy matrix, so you have to know the names of what is the thing. So you use the Kevlar fiber and epoxy matrix in order to have this type of wind turbine, alright, marine wind turbine. Okay, and so you can see often it's talking about lightweight again, alright, good stiffness, high strength, alright, and things like that. Can also add on is that carbon fiber composite is something that we often use normally now, is that it weighs about 1/5 of the steel, but as good or better in terms of stiffness and strength. So this is a sentence that you can although said is memorized, but it's pretty much easy to understand also. So straight away install inside your brain already. This page is talking about the car. So if I were to click in this link, you will actually go to the car side. Okay, so you can read it up and see which are the things, but most probably fuel efficient, fuel economy. So because lightweight, so you reduce the weight and it will be easy, it will be more fuel efficiency. I mean, yeah, I think you get what I mean. The next things that I see for the composite itself is this sentence, able to tailor materials. You can go to page 10, which I have also discussed in previous videos. but I just want to talk about it again, is that you are able to tailor-make your material based on the things that you want, based on your particular applications. If you want it to be hard, alright, then you just design in terms of hardness, then the rest of the thing you can forego. For steel, it is hard but it is heavy and things like that, so there is other properties that you don't want. So for composite, you can design whatever things that you want while taking off whatever things that you don't want. So this is something that you can write in terms of your so-called theory questions, alright, and which enables efficient materials utilization. So you will not have any waste of material, alright. And nonetheless, is a designer properties where you can optimize whatever stiffness you want and the strength that you want, and also manufacturing requirements. So you can play around with all these things in order to acquire an optimum design method, so that it can be used throughout the composite making process and design process. Alright, so all in all, these are all the application stuff that you may want to understand in order for you to go on to the exam questions for theory applications of composites. And last but not least, this is the page, and this thing is talking about the strength to weight ratio, which is the specific strength. Over here, this is specific stiffness, so it's the stiffness to weight ratio. Alright, over here in the x-axis is the strength to weight ratio. Over here is the stiffness to weight ratio. So whether you want it to be very stiff. This means that it's like what is considered stiff. So the opposite of stiff, I would believe, is ductile. So ductile means that it's very elastic. So stiff is not very elastic. So this stiff is good because it's pretty hard. Alright, so once you hit it, it's very hard to break. But stiffness cannot so-called tank impact, meaning once if you drop it on the floor, it will break. Very brittle. So stiffness, the disadvantage is brittleness. Alright, so this is a chart to symbolize or to represent the strength versus the stiffness. Alright, strength versus stiffness. Alright, as you can see, the ceramics itself, alright, is high strength, high stiffness. So this is something pretty good for you, while also maintaining a good low weight. Alright, as you can see, is a strength to weight ratio and stiffness to weight ratio. So from this chart itself, you can see that the ceramic is high strength, high stiffness, but low weight. Okay, correspondingly, this is ceramic. Ceramic is high brittleness. Alright, so composite is in between. Alright, so composite is not very stiff, which is also good because it is absorbent, energy absorbent, so it will not be very brittle. Okay, so composite is somewhere over here. Okay, and these are the things that you may want to also explain in order to be able to articulate with this chart, if happen that they ask you to articulate this chart, things like that. So the wood, things like that, the glass, everything, I think you can oneself see lah. But it looks like a finger lah, you see your index finger. But anyway, yeah. So I think over here, if I zoom in, it says that the chart shows the compressive strength of the material, or the tensile is typically 10% of the compressive. So this means that it is very good for compressive strength. However, its tensile strength is much weaker than the compressive one. Alright, so if you were to pull it, it is more likely to break. Alright, while if you were to compress it, it is more easier to tank, or is better. So it is for ceramic. Alright, it is easier for you to design something that is for compressive purposes. Alright, yeah. So for other materials, strength in tension, compression, I think is about the same. Okay, so I don't know what the hell, but at least something for you to say. And therefore, this is it for this lesson. And next lesson we'll talk about. See you there.